Good morning, guys. In our previous lecture, we have seen the error detection method for single parity bit and two-dimensional parity bit. Now, our third error detection technique is checksum. Now, we are going to detect the error using checksum method. Checksum mechanism. Now, let's see what is checksum method. Now, see, checksum refers to sum of bits calculated from digital data that is used to ensure or check the integrity of data at receiver end. That means checksum refers to sum of bits calculated from digital data. Now, checksum is nothing but only the sum of the digits, sum of the bits which are going to transfer on the network. Now see how the checksum method is work. Now working of checksum is given as at sender end. That means before transmission we have to start with the sender end. The first step is data being transmitted is divided into equal sized k number of segment where each segment contains m number of bit. Here we can say that k and m are the variable that can be of any size, but the length of data, whole length of data is going to divided into k number of segment. First we have divided the data. Suppose that this is our length of data, then first we have to divide the k segment and each segment have number of bits. This is called m number of bits. That means here if we are going to see that 1 2 3 segment, that means value of k is 3 and bit 1 2 3 4 5 1 2 3 4 add 5 0 1 2 3 4 5. Here m is 5. That means we can have the length of the bits as 2 to the power, that means 8 16 like this. But for understanding, this is the division of the data transmitted. Now so first step is divide the data into k number of segment and each segment have m number of bits. Now our second step is the divided k segment are added using 1's complement and extra bits in case of more than m bits are added back to the sum wrap around. That means if we are going to add all k segment to each other, then if there is any extra bit found, that means if our size of m bit is 4 and after summing the data, sum of the data, the bits is going to be of the length of 5 bits, then fifth bits, that is extra bit, is going to again added into the 4 bits, and this is called wrap around. That means sum wrap around. Now our third step is the final sum complement is calculated. Now the whatever sum calculated, now we have to find the complement of that sum, and the complement of the final sum is called checksum. The complement of final sum is called checksum. Now all k segment is sent along with checksum. Now all the data k segment and this checksum is added with attached with that data, and now this is ready to transfer. Now when we are going to transfer this, now what happened at the receiver end? Now see, at receiver end step 2 is repeated at the receiver end and all the data segment are added to get new sum. Now when receiver receive the data units, now the receiver also get calculate the sum of the k segment. Now when the new sum is calculated, then we have to add the received checksum and the complemented. Now when we have got the new calculated sum, then add the checksum to that sum and the final sum is going to calculated. And now we have to find out the complement of that data. If the complement is all zeros, the transmission is accepted, that is no error. If all the complemented is all not all zeros, then data is rejected. That means erroneous. There is error in the data and the retransmission going to take place. Now if we are going to see this with the help of figure, you can see that here k equal to 4 data segment with m equal to 8 bit. Now your data units, these are the data units. Suppose that this is your data being transmitted are these are your data. Now see first step, these are your data. Now first of all we have to divide each data into k segment. Now if we are going to divide this data like this, suppose that 1 2 3 4. Now this data is going to divide into 4 segment. Here k equal to 4, there are 4 segment 1 2 3 and 4. Now calculate the bit number of bits in each segment. 1 2 3 4 5 6 7 8. That means m is equal to 8 bits. 8 bits. Now this is our first segment. First going to divide the length of data as into segment, k segment. That means we have divided into 4 segment and each segment have 8 number of bits. Now this is your first step. This is the at receiver end, sorry, this is the sender end. This mechanism is at sender end. First, now data unit 1 and data unit 2 will be going to sum up. Now we have sum and wrap the around extra bit. Now see what is this. Here at receiver end, sorry, at sender end, step first is divide k segment into 8 m bits. We have divided. Now all the sum are going to, all data unit are going to added. Now here 4 data unit 1 2 3 4. Now we have to take first 2 data unit. Now take 1 0 1 1 0 0 1 1. Now second one is 1 0 1 0 1 0 1 1. Now we are going to add this. I hope you are aware to binary addition. Now take the result. 1 plus 1 0. Again carry bit is 1. 1 plus 1 0, carry bit is 1. 1 plus 1 again 0 and 1 is carry bit. Carry bit 1 is added. Now this is 1. And again we have the 1 carry bit. So 0 plus 0 0 and 1 carry bit is gives 1. Now here there is no carry bit. 0 plus 1 is 1. 1 plus 0 is 1. Again 1 plus 1 is 0. We have take the 1 carry bit and this carry bit is going to added here 1. Now 1 plus 1 is 0. 1 carry bit is written in the last. This is the your sum of 2 data unit. Now here we can, if we are going to count this number of digits, here you can see that 1 2 3 1 2 3 4 5 6 7 8 9. But we have to take the maintain the number of bits as 8 bits. Now this is your extra bit. Now this extra bit is again going to sum here. We have to sum this extra bit here. Then add this extra bit. This extra bit is transferred here. Now we got the sum. This will, now your sum is 0 1 0 1 1 1 1 and 1, because 0 plus 1 is 1. Now if we are going to see the sum is, what will be the sum? Your sum is 0 1 0 and 5 times 1. Now check the number of bit 1 2 3 4 5 6 7 8. Now again the third data unit third, that means this data unit is going to added in the final sum. Now we are going to add the data unit third. So third data unit is 0 1 0 1 1 0 1 0. Now add this, you will get the result 1 plus 0 1 1 1 0 carry bit 1 1 plus 0 1 and 1. Your 1 is your carry bit. 1 plus 1 again 0. Now again we have the carry bit 1. Now 1 plus 1 0 and 0 plus 1 carry bit is 1. Now again 1 plus 1 0 1 carry bit 1. Now here 0 plus 0 1 carry bit 1. 1 plus 1 0 carry bit is 1. Now the sum is 1 0 triple 1 0 0 1. Now count the number of bits 1 2 3 4 5 6 7 8. There is no extra bit, so again we are going to add the fourth data unit. Fourth. What will be the data unit fourth? You can see 1 1 0 1 0 1 0 1. This is your fourth data unit. This is your fourth data unit. Now this will added into that. Now let's add the data unit 4. Now add data unit 4. 1 is 1 1 0 1 0 1 0 1. Now add this again. Now find the sum of this 1 plus 1 0 and here carry bit is added 1. Now here 1 1 1 plus 1 0 1 plus 1, because here 1 and 1 we have the carry bit 1. 1 plus 1 is 0 1 plus 1 0 1 plus 1 plus 1. That means 1 plus 1 is 0. We have the carry bit, that means this is the 0 and 1 our carry bit. Now if we are going to count the number of digits 0, then 1 2 3 4 5 6 7 8 9. That means here 1 bit is extra. This is the extra bit and we have to add this extra bit here. Now all the data 0 0 0 0 and 1 1 1 1. That means 4 0 and 4 1. Final sum is now check the sum again. 1 plus 1 is 0, carry bit 1, 0 plus 0 plus 1 1 1. Here 1 1 plus 1 0, carry bit is 1 1 and 1 0, carry bit is 1 1 plus 1 0, carry bit is 1 and 1 plus 1 0 and 1 carry bit. We have the calculated 1 carry bit also. This is the main important thing is to calculate the sum. Your sum must be correct, because 1 plus 1 0 and 1 carry bit is 1 and 1 1. This is the one is the extra bit. Now our final data will be our final sum. What will be the final sum? Final sum is, now if we are going to add this 0 plus 1 1. Now there is no change in other bit. This will be 1 1 3 times 1 1 1 3 times 0 0 0 0 and 1. This is your final sum. Now this is your final sum 1 triple zero 4 times 1. Now we have to calculate the complement of this sum. Now we have to complement, find out the this is your final sum. This is your final sum. Find complement. If we are going to complement it, complement, that means 1 converted into 0, 0 converted into 1. Now 1 is complemented as 0, 0, 0, 0. That means 4 times 0, and triple 1, 1, 1, 1, 0. Now this is your checksum. This is your checksum. Now we have calculated the checksum. Now this is your checksum, 0, triple 1, 4 times 0. Now this checksum here, this checksum is going to attach with this data. Now we have attached the checksum with this data, and this data is going to merge with one segment, one more segment. This is called your checksum. Checksum is 0, triple 1, and 4 times 0. Now this 4 segment and one checksum is going to send on the network. This is your checksum. Checksum. Now the process at the sender end is completed. Now when these data are transferred and received at the receiver end, then what will be the mechanism at the receiver end? So let's see. At the receiver end, these all data units are calculated as we have now calculated. जैसे भी हमने स्टेप 2 से लेकर 4 तक किया है, ये सारे स्टेप ऐसे ही डेटा यूनिट कैलकुलेट होंगे. और द फाइनल सम इज we have to get the final sum. Now at receiver end, add all data units as we had previous. As we had previous. As we had previous. Now the final sum is 1, 0, 0, 0, 1, 1, 1. This is your final sum. We can say that your final sum 1, triple 0, 4 times 1. Now at this end, up to the final end, final sum find out करते तक सारे स्टेप सेम रहेंगे. When the receiver find the final sum, then receiver add the checksum to the final sum. Now add the checksum to the final sum. Now add checksum to final sum. That means this will be your final sum is 1, 0, 0, 0, 1, 1, 1, 4 times 1, and your checksum is, what is your checksum? Now see, your checksum is 0, triple 1, and 4 times 0. This is your checksum. Now add this checksum here. 0, triple 1, and 4 times 0. 1, 2, 3, 4. Now find the sum. Now find the sum is 1 1 1 1 1 1 1 1. Now this is your final sum. This is your checksum. Now we have to find the complement of this. Complement of this. If we are going to find complement, then it will becomes into, we have to find the complement of this data. Now complement 1 0 1 0 1 0 0 0 0 0 0. Now all the zeros, all the complement are 0. This is your complement of final sum. And all the complements are 0. As you can see that all the complements is 0. Then all complements are 0. Then data is accepted. So our transmission is successful.